I'm Fry, Haddington's Chief Language Officer. Our first webinar on DDE was an intro to an extensive tour of the help system. You can see it from the webinar page on hdrobotic.com. And here's that page. It has both webinars on hardware builds as well as software. There's one thing I want to make sure you remember from the first webinar, which is this question mark in the upper right-hand corner of the screen. That takes you to documentation about the help system. So if you only know one thing about DDE, know about how to find the help system, and it'll help you help yourself. This second webinar is where we'll introduce making jobs and controlling Dexter. We'll be using DDE version 2.0.12, which was released today, August 22nd, 2017. First, a brief tutorial on defining functions. Let's get into our editor page, and I'll create a new buffer. Okay, first I'm going to insert one of DDE's utility functions for making sound. You can find it on the menu here, beep with options. All right, with no selection in the editor buffer, I can click on eval, and it will play two notes. It plays two notes because there's first a primary note, and then there's a callback function of what to do after it's done with that first note, and that is play a second note at a slightly different frequency. Okay, so that's a function call, but how about defining a function? Let's select it, go to the Learn.js menu, down here at the bottom for functions, and named function definition. Now watch this. As soon as I click this guy, it wraps around the selection the header and last closing brace for creating a function. So we're defining a function named foo, takes two arguments x and y, which we do nothing with at the moment. Click on eval, and we now define that function. We can tell that it's defined by selecting it, clicking eval, and you'll see it appear down here in the output pane, and we click on this triangle and it'll show you the source code. Okay, so now let's make a call to this function. We'll just call it with no arguments. Select, click eval, and it sounds just like it did before. We've got a function, we've named it foo, it's calling the source code in it. Okay, let's do a little manipulation of the arguments here. Let's change this argument to 1. And let's change the duration to 1. This is the duration in seconds, so we just change it from a half second to a second. Okay, now if I click eval on the whole screen, we'll redefine this function and call it with those default arguments. Okay, so the first duration lasts a little longer, but it's just using the default for that argument. So let's pass it in something greater. So we'll put in 2 seconds now. Okay, and now I'm not going to redefine the function. I'm just going to make the call with this argument. Oh, wait a minute. I made a mistake. I should have this duration be x. Okay, that looks a little better. Okay, now I am going to redefine the function. Okay, now when I call it with 2, okay, so I hope you can hear we got a considerably longer beep that time. You can think of functions as verbs and their arguments as adjectives that modify the behavior of the function. Okay. Well, now that we got a little detail about how to define functions, we're going to move into jobs. Functions are crucial because functions themselves can be instructions on a job's do list. So we will revisit functions in a minute or two. All right. A robot is a machine that can perform operations in its instruction set. The core functionality of DDE is to help users create such instructions, organize them into processes that we call jobs, and orchestrate sending each instruction at the right time to the job's associated robot. The job defines a process to be run on a robot. The core of this process is this sequence of instructions to be delivered at a particular time to the robot. You could think of each instruction as a musical note to be played on a robot instrument. In a later webinar, we'll talk about literally playing musical notes in DDE, but for this webinar, our notes are to be played on a Dexter with Dexter just moving. The primary instruction that we want to send to Dexter is called move all joints. It takes 5 numbers, which are degrees that we want the 5 joints of Dexter to move to. Okay, I want to get a new buffer here, and we're going to be spending a lot of time on the jobs menu throughout this webinar. The first item is help. So click on help and you can see a whole bunch of examples of jobs, what all the arguments are. There's lots of stuff about jobs. So after this tutorial, please click on help on the jobs menu and you can read it all. All right. Another item I want to point out on this menu is the simulate menu. So simulate has 3 values: true, which says run our simulation down here in the simulation pane in the lower right. Also false, just run it on Dexter, or both. For this tutorial, we're just going to be running the simulator. And I would recommend in general that you try all your jobs in simulation mode before you actually try to move Dexter. Okay. The first jobs menu has lots of examples on it. So as you can see, there's a dozen of them right here. We're going to cover the first 4 in this tutorial. So let me insert the simplest. Here it is. You just click on it, insert it. Okay, here's our simplest job. What have we got here? We name our job, and we have a do list of 1 instruction. This is an array of just 1 item, okay? And then we're creating instance of new jobs. We're creating instance of the job class. Okay, I can click on the eval button. And when we click on the eval button, 2 things happen. We create a new button down here in the output pane header with the name of my job. Now, my job is colored gray because this job hasn't been started yet. So you can put your mouse over the button and find out the status of the job. This job has actually never been run before. Okay, the second thing I want you to notice is calling this function returns the instance of the new job. And down here at the bottom, we see an inspector that allows you to browse complex data structures that are created by eval. This inspector is new in this version of DDE. It's worth paying attention to because, well, lots of knowledge down here, and you'll learn about the system a lot. Okay, so let's take a look at the fields of our instance. We've got a name, my job, the class, a job, highest instruction completed, so this lets us know how far we got. Maybe we erred and we want to understand where it stopped, but we haven't even started yet, so this is set to -1. Each job has a job ID, a unique integer. This is the first one we created, so it's number 1. And we cache the original arguments for use when restarting the job. That's what this orig arg is about. A job has a program counter. A program counter says, where is the job or which instruction is the next instruction to be executed or currently executing within the job. We're on 0 because we haven't started the job yet. Next, we've got a robot. This gets the default robot since we haven't specified a robot yet. Dexter 0 is the default robot. We've got another thing, instruction queue. Let's not talk about that. It's a little fancy. The last item here is status code code which is not started. Okay, one of the things we can do in the inspector is click on these links to get to other data structures. So I'm going to click on Dexter 0 and take a look at what's going on inside our robot. Okay, it's got a name, the string Dexter 0. It's of class robot Dexter. We actually have 4 different kinds of robots in DDD, and we'll go over others of those in future webinars. It's got a current series of angles. It's at 00000 right now. And what else is important here? It's got an IP address here. It is not connected. It's got a port of 50,000. There's a pose. Simulate is null. Now, this is important. If normally simulate is either true or false, but when it's null, it means we want to get the real value of simulate from this menu item. So here's our menu item. We selected it true. So when it comes time to actually send an instruction, the code looks up what's the value of simulate, says, oh, it's null. I got to go get it from the menu, looks on the menu, finds it's true and returns true, and then we simulate. Okay, so now we're going to run the job. Okay, so when we click on here, it will actually start executing the instructions in the job. All right, now what happened? Well, first of all, as soon as I clicked, you saw that the button flashed green. It turns the color green when a job is running. It only had one little instruction, so it didn't last very long. It also brought up the simulator, and you can see a representation of Dexter here in the lower right. Now, since we didn't actually do any instruction that caused Dexter to move, it remained straight up and nothing really happened in the window, but just so you get familiar with it, that's what the simulator looks like. Okay. We also see down here, there's a progress bar. So this says what's happening with the current job. So the current job is called My Job. Remember our name, My Job. The program counter is at 2 of 2. So there's only 2 instructions on this. Now up here we only see 1 instruction, but DDE throws in an instruction or 2 to help it with operations, know what the status is, etc. Okay. Now, I want to go back. We're in our inspector here. I can use this arrow and go back to our instance of job. Okay, so we're here back in an instance of job. And now, if you notice, there's considerably more items in the data structure. That's because running the job caused other things to happen. For example, it's got this robot history, right? We call it robot status. You can click on that and see some things about what's going on with the robot. These are some internal details of the robot, including its angles, etc. Not too much activity in this one because we didn't tell the robot to do anything, but we'll see something of that a little later on. Okay, here's sent instructions. These are the instructions that were actually sent to our robot or our simulator of the robot. We did send a couple of instructions there, these G instructions, which are really get the robot status. So they're sent behind the scenes just so the IDE can be up to date with what's happening with the robot. And let me see what else. We've got a start time for the robot, a stop time when this job started and stopped. You can see it took a second or so. Let's see, it's got a stop reason, finished all do list items, okay? And here's our status code again. This time it's completed instead of not started. So we can use the inspector to see many things about what's going on inside the robot and help us. Now you notice in this progress bar, there's also an inspect button. So if we click on this inspect button, we also get the current instance of the job, and here's what it looks like after it's been run. Okay, I want to go back up to the do list here. You'll notice that we've got one item on the do list. It's called robot.out with an argument of hey. All right, now we can select that item and evaluate it. Now, one of the things about evaluating this is when the job is defined, when we're executing this new job, this evaluation happens. It's just JavaScript code. We're evaluating all the code. Okay, so what did we get when we evaluated this? We got a instruction control.out. So this is a specific instruction in a robot, and it has fields of, hey, that's the value that's going to be printed. Don't worry about this temporary value right now. It's got a color that it's going to print it in. If we scroll back in our output pane to where we were before we started inspecting this, I'm not seeing what I want to see. So let's run this. Here's what I wanted to see. Okay, right below our progress bar, we have this job : my job instruction ID 0, hey. Okay, this hey is that hey. We're printing out a string, so it's just like the out function, but instead it's a regular instruction, and the instruction adds this extra stuff to it, telling you which job it came from and which instruction within the job it was at. Okay, let's, I want to move on to another job. Let's clear this screen here. I'm going to select the second example. This is a slightly more complicated example, and you notice this one has lots of comments around. All this brown text comments to help you know what's going on in this job. Okay, so here we've got a name, my job again. This time we've got two instructions, robot.out, that's what we had first time, and here we're calling a function, and this is out second instruction. Okay, so now this function is also just evaluated. So if we like, we could evaluate this guy and get an error because I didn't select the right stuff. And, let's try again here. I am missing something, and I'm not sure what it is here, but try one more time here. Okay, well, let's forget about that. It's a little hard to select all the delimiters here. But I can select the inner part of this function. This is the body of the function. It's just a call to the function out. So I click on that, and it just prints second instruction. And if we'd like, we can click on out itself, get our click help on it. You can see out. I click on out, scroll the documentation pane telling you about all the args, you know, what color it's printing, all that sort of thing. Okay, so let's run this job. First of all, I'm going to say option click on new. It selects the whole thing. I click on eval, and we've now created our job. And now we've got my job on here. There's something else I want to call your attention to. We can also start the job programmatically. So this, what I've highlighted, job myjob.start, is a function call that does the same thing as clicking on this. In fact, you can do either one. Doesn't really matter. Let's just eval it for this time. And now we've run our job. We can see we've got a program counter of 3. It's done. We can inspect our job. You know, okay. So what else happened here? We've got some printouts. So our first instruction, see this string right here, first instruction, okay? So that was printed right here, first instruction with our job, my job, and the instruction ID, and then second instruction came out with this second instruction right there. So 2 different ways to get print statements. Robot out is a little bit better because it tells you where it came from. All right, I want to move on to our third example. So this is number 2. Okay, and now we're finally going to get Dexter moving. Okay, so here's our job, new job. It's called job 2, option click on new. We select the whole thing. I click on eval to define it. We got our new button down here. And now let's take a look at this before we run it. So we've got 2 instructions on here. a call to Dexter.moveAllJoints, and it's just moving it straight up, 0, 0, 0, 0, 0 is the home position. Then we've got another one called move to, and this moves to an X, a Y, and a Z position. Okay, so we're moving to an X, Y, Z. These dimensions are in meters, so we've got X is 0 meters and Y is half a meter and Z is a few centimeters. Okay, and then these other things are about the configuration of the joint angles, so where they go. There's multiple possibilities. I'm not going to go over them right now, but there's just, because it's 5-axis instead of a 3-axis robot, there's multiple ways in which Dexter can position its end effector to a particular place. You can imagine with your elbow up or an elbow down, your hand could still be in the same place. All right, let's run this job. Whoops. Click on that guy. Oh, we already do that? I guess we already did that. Okay, now I'm going to click on Start. And if you noticed over here, our robot did something. It went somewhere. So, and we got 5 out of 5 done, so it looks like it went okay. We can rerun the job. There's no need for that to be highlighted. We just click on this button again. In fact, if we look at the tooltip here, when it's purple, this job is successfully completed. Click to restart it. Click to restart. And you see that it turns green for a while, and while it's running, and then it goes to purple when it's done, and our robot has, in fact, moved a little bit. Okay, so I have just one more example I want to show in this webinar. And, whoops, wrong menu. Okay, here we go. Dexter and functions. Okay, this is a little more complicated than our previous one, but not too much. Okay, first let's focus in on our job. Here's our job, and what do we got here? Our do list. Do list has move once and sleep and move. Okay, these are both functions that are defined elsewhere. Where are they defined? Well, they're actually defined up here, and we better define them or we're going to error. So we are calling two functions as two top-level instructions, and when they are called, the first one, move once, we'll call move all joints with these angles. The second one we'll call move all joints, sleep for 2 seconds, and then call a move to. Okay, so we've also are defining a robot in here. Now, often you will use just the default robot but just to get used to the idea, we can define a robot. We're going to call this one myDex. Simulate is null. That means take the real value from the simulate, which is still true. Okay, so here we go. I'll define that robot, and let's define our job. Now, before I run this, let's take a look at move once, okay? I can evaluate move once, and we get a function. So here's our function, and same thing for this guy, sleep and move. Sleep and move is the name of a function with parameters, nothing, because it doesn't take any parameters. Okay, ready? We're now gonna run job number 3. I click on the button to run it, and you can see it's still running, moved a little bit. You can see our tooltip here. The job is running, doing a couple moves, and then finally done, okay? So I'm gonna click on it again, and things to pay attention to here are what's happening in the simulate pane. You'll see that move. We've got a sleep instruction here, so it is sleeping for 2 seconds in the middle of the job, and then it has a final move to at the end. Okay, so I'm clicking to restart. There we go. It's green while it's running. You can see, ooh, sorry, got a phone ringing, but, our job completed successfully, turns purple. If you put a mouse over the button, you can see this job has successfully completed. Click to restart. Okay, That is what I wanted to cover in this webinar. So a little review. We recommend you go up to the jobs menu, click on help, and then you can try all the examples from our examples that we did here. These other examples are much more advanced jobs. We will be covering those in subsequent webinars. Our next one, however, is going to be how you can write custom user interfaces, GUI interfaces for users of your jobs. That's it for now. Thanks for listening.